Hello children, welcome to aimstoday online classes. This is a chemistry session. In this we are discussing about the chapter periodic classification. In this session we are going to see about the earlier concepts for classification of elements. That means nowadays we are able to see certain periodic table in our classrooms or in our school. Have you seen ever? Yes, that is called modern periodic table. But it is not the first classification. It has not derived directly. Before that, so many scientists they have kept their efforts in classification of these elements. They have tried to classify the elements into different groups and batches based upon certain concepts, but they were failed. But even though they are failed, they have given a corrective, they have laid a correct path for the modern classification of elements. So we can say those earlier concepts or earlier classifications of elements as important failed concepts. But as they are failed, they have given the correct path for the modern classification. That is why who classified those and how they have tried to classify the elements. These points are must to be known as a student. So now in this class we are going to see about those earlier attempts for the classification of elements. Okay. Before that, let us see what is the necessity for the classification of elements. Is it needed for the classification of elements? Yes, of course. In the beginning of the 18th century, only few elements were known and hence it was easy to remember the properties of these elements individually. If there are only few elements, what happens? We can remember them very easily even though their properties. But what happened by the discovery of new elements, which is presently about 118 elements they have discovered so far, isn't it? So it is very difficult to remember their properties individually. As there are so many elements, remembrance of the properties of each and every element individually is a big task. We are not able to remember them properly because as there are so many elements, if there are only few, they could remember those very easily. But as the number of elements increased, it became difficult to remember them. Thus, it was felt at the time the need of some simple method to simplify the systemized study of properties of these various elements and their compounds. So then, as the number of elements increasing, scientists they have thought that it is necessary to classify these elements into certain batches so that we can remember the properties of these elements in the convenient way and even their compounds formation also. Okay, in that way they have tried to classify. This necessity led to the classification of various elements into different batches or groups. Okay, so what happens when elements are classified into batches? That is a advantages of classification of elements. Yes, there are some advantages by classifying the elements into groups or batches. What are those? First one is we can study the elements in systematic manner. Yes, by grouping them, we can we can study the properties of the elements in the systematic manner. Suppose there are certain elements classified into one batch. Now we can say the properties of all the elements in that batch will be similar. If we know the properties of one element, the same can be accepted from the remaining elements also almost. In that way, it is made very easy. Next, we can correlate the properties of the elements when they are batched. If they are grouped into one certain batch, certain elements, if we know the properties of one elements among those, so then the same properties can be correlated with the element properties of the other elements in the same group. And even we can know the type of different compounds that different elements can form. Yes, the elements classified into one batch will form almost a similar type of chemical compounds. In the similar way, they react with other elements. In that way, we can, by the correlation, we can remember the properties of the all the elements present in the same batch very easily. Now, let us see here the earlier attempts for the classification, how they have tried in the earlier days what are the limitations in those classifications, how they have given idea for the modern classification. Let us see those all. Okay. Earlier, many attempts were made to classify the elements for better understanding. Now let us see here the important attempts among them. So first among them is Lavoisier's classification into metals and non-metals. By the late 1860s, Antony Lavoisier classified the elements based on similar physical and chemical properties into metals and non-metals. So, for the first time, Lavoisier classified the elements into two groups. They are metals and non-metals. So, what are metals here? The elements which has the properties like luster, good conductor of heat and electricity, ductile, malleable, and solids at room temperature and have tendency to lose one or more electrons are classified as metals. So what are the properties? Based upon the certain physical properties, he classified certain elements as metals. So what are those properties as he had taken base? Those are luster, means those elements which are having a shining property, and good conductor of heat and electricity, and they are ductile, that means they can be drawn into thin wires, and even they are malleable. What does it mean? They can be beaten into thin sheets, and they are solids at room temperature and have the tendency to lose one or more electrons so that they can form positive ions. So those elements which are having these properties he classified as metals. For example, we can say some metals like iron, copper, zinc, gold, aluminium, silver. These all will come under metals. These all elements they show these properties. Okay. Next, one more category, non-metals. An element which has the same properties like no luster, bad conductors of heat and electricity, non-ductile, non-malleable, and has a tendency to gain one or more electrons is classified as non-metal. So the elements which are having quite opposite properties to that of metals are classified as non-metals. What are those? Non-luster means they won't shine. Bad conductors of heat and electricity, and even they are non-ductile, means they cannot be drawn into thin wires. They are non-malleable, means they cannot be beaten into thin sheets, and have tendency to gain one or more electrons to form anions. Those elements which are exhibiting these properties are classified as non-metals. For example, copper, sulfur, nitrogen, oxygen, hydrogen, these all elements they exhibit these properties, hence they are classified as non-metals. Okay, in this way he classified elements into two batches, but there are this classification is rejected because of certain limitations. So what are the reasons for the rejection of this classification which was done by Lavoisier into metals and non-metals? Let us see here. One of the first among them is the elements were divided only into two broad categories, which does not help much in study of elements. Yes, here classified all the elements into only two batches. Those are metals and non-metals. But this does not help much in understanding the properties of the elements in clear. For example, if you see metals batch or metals group, in that only all the metals are kept in the same group. For example, sodium, potassium, these metals are kept in the same group along with some other metals like gold and silver. If you observe the properties of these, gold and silver are least reactive metals, whereas sodium and potassium, these metals are very reactive metals, but these all kept in the same batch, that is metals. So in this way, it made a little confusion still. It is not giving any clarity in the classification, understanding the properties of elements. So it is rejected. That is one point. One more point for the rejection is there are some elements which have the properties of these metals as well as non-metals. For these elements, there is no separate categorization. Those elements are called actually nowadays metalloids. The elements which can show the properties of both metals and non-metals are called metalloids, but he could not classify these elements metalloids into another separate group. He arranged or fit these elements also into either into metals group or non-metals group. But these elements can show or exhibit properties of both the metals and non-metals. These are called specially metalloids. So this also we can say as one of the limitations. Let us hear some examples for the metalloids like boron, silicon, germanium, arsenic, strontium, tellurium, polonium, and astatine. These all will come under metalloids, and these elements can exhibit the properties of both metals and non-metals. So there are major drawbacks which are led to the rejection of Lavoisier's classification. Okay, next to him, Dobereiner. One more scientist, Dobereiner, he tried to classify the elements. In 1817, Dobereiner classified the elements into groups of three elements, such that three elements had similar properties. And he observed one more interesting point also. When these three elements are arranged in the increasing order of their atomic masses, the atomic mass of the middle element is being equal or nearly equal to the arithmetic mean of the atomic masses of the first and third elements in that group, and he called this group of three elements as triad. In the honor of his name, these elements are called Dobereier's triads. Okay, lithium, for example, lithium, sodium, potassium is a Dobereier's triad. In this, these three are written in increasing order of their atomic masses. Because the lithium atomic mass is 9, whereas for the sodium it is 23, and for potassium it is 39. So these are written in the increasing order. After writing them in the increasing order, it was observed the atomic mass of the middle element, that is sodium, is equal to arithmetic mean of the atomic masses of lithium and potassium. If we take the arithmetic mean of these two atomic masses, what do we get for 9 and 39? 46 by 2, that is 23. So in this way, the atomic mean of the atomic mass of the first and third elements is being equal or nearly equal to atomic mass of middle element in these triads, and the chemical properties are also being same for these three elements. These set of three elements are called triads or Dobereier's triads. Let us see some more examples for these Dobereier's triads. Actually here, chlorine, bromine, iodine is one set, calcium, strontium, barium is one set, sulfur, selenium, tellurium. This is one more set. These are three element sets are called Dobereier's triads. If you observe here, the atomic mass of the middle element is being nearly equal or equal to arithmetic mean of the atomic masses of remaining two elements. So these are called Dobereier's triads. But this theory is also rejected because of some disadvantages or limitations. Let us see what are those disadvantages of these Dobereier's triads. The main drawback is this classification was in this classification the concept was not applicable to all the known elements, but only up to limited number of elements. That is why this theory or this classification was rejected. He tried to classify the elements into set of three elements, that is into triads, but he could not classify all the available elements, all the known elements at that time into these triads. He could not classify them almost to many elements. So he could classify only limited number of elements into triads. This is a major drawback, which is major reason for the rejection of Dobereier's triads. However, one point became clear here, that the properties of the elements have some relationship with their atomic masses. So, as we told at the starting, these classification earlier attempts, even though they are failed, they are important. See here it is a known point. Even the Dobereier's classification is failed. They came to know one point that there is certain relation between the properties of the elements and their atomic masses. So based upon this point, later they have some more scientists they have tried to classify the elements. So let us see one more classification the same way. Next, Newland's classification into octaves. John Newlands, an English scientist in 1866, arranged about 56 elements known at that time in order of their increasing atomic masses. So, according to Newland's law of octaves, when elements are arranged in the increasing order of the atomic masses, there is a repetition of the properties of every eighth element as compared to the given element. So what he observed? He written all the available elements at that time, around 56 elements. He written in the increasing order of their atomic masses. Then he observed an interesting point that the chemical and physical properties of one element are completely resembling with the consecutive eighth element for that. So he called this set of eight elements as one set and he could name them as octave. So in the honor of his name they are called Newland's octaves. Okay. These are there are seven musical notes according to Indian system. I think you know these. The musical notes are sa re ga ma pa da ni. In the musical notes, there is a repetition of the same note after a gap of 7, isn't it? If you say these 7 notes, what do we get as the 8th note here out of this completion of these 7? Again, the sa will come here. We often sing this sa re ga ma pa da ni sa. Again, 8th one is exactly similar to the first one. The same it was observed by Newland in the chemical elements also. So by coincidence, Newland found the same pattern in the arrangement of the elements also. For example, if you see the arrangement of elements in this way, here we have to remember one point that while he was given this classification, they didn't come to know yet about noble gases. Suppose he has given classification or arranged elements in the increasing order of atomic masses like this: helium, lithium, because they didn't come to know helium yet, hydrogen, lithium, beryllium, next boron, carbon, nitrogen, oxygen, fluorine, next sodium, because they didn't come to know still no neon, sodium, next magnesium. In this way, elements were arranged in increasing order of atomic masses. Now, the properties of one element are being similar to the consecutive eighth element. Suppose if you see lithium, for lithium, the consecutive eighth element will be, if you count, 1, 2, 3, 4, 5, 6, 7, 8. That is sodium. Now the properties of lithium are resembling with the properties of sodium. So this set of 8 elements he considered as one active. If we see beryllium, the properties of beryllium will be similar to that of the consecutive eighth element for it. What will be consecutive eighth element? We count 1, 2, 3, 4, 5, 6, 7, 8. Magnesium. So the consecutive eighth element for beryllium is a magnesium. Now these two elements are having similar chemical properties. So this was found by Newland. These elements placed in the same vertical row. So the elements which are having the same chemical properties, he arranged in vertical column. He called this column as group, have common properties. The elements, for example, elements beryllium, magnesium, and calcium are grouped on similar basis and they have similar characteristics also. Okay, that is a Newland's classification. But in this also there are some disadvantages. Let us see what are those. This law could be best applied only up to the element calcium, even though he has tried to classify the elements more than 50. But this theory or this classification into octaves is fit for the lower elements till calcium only. It is not exactly applicable for the higher elements. One more major drawback is newly discovered elements like noble gases could not fit into this octave structure. So when after this classification, scientists they have discovered noble gases, but they could not be fit into this classification because if you see after before hydrogen there should be helium, and here between fluorine and sodium there will be neon according to the increasing order of atomic masses. Now, after writing neon here, if we observe for lithium now, the consecutive eighth element will not be sodium, because if you count from lithium 1, 2, 3, 4, 5, 6, 7, 8, neon is a consecutive eighth element for lithium now, where these two are entirely having different properties. In this way, the discovery of new elements, noble gases, led to the failurity of this Newland's classification. Okay, one more. It failed to exhibit these feature with the higher elements. As we told in the first point, it is not applicable for the higher elements. It is applicable, or in this, it is applied only for the few elements, the total calcium only. Okay, next classification. Mendeleev's classification. Now, this was the most successful attempt among all the earlier attempts at the classification of elements. Yes, in fact, Dmitry Mendeleev is known as the father of the periodic table, because earlier to him, many scientists they have tried to classify the elements into different groups. But for the first time, Dmitry Mendeleev, classified the elements, and he arranged all the available elements at the time, all the known elements at the time, into a tabular column based upon the properties. So that is called periodic table. So the first periodic table was given by Mendeleev. That is why he called as father of more periodic table. Okay. He had noticed a relation between the atomic masses of the elements and their physical and chemical properties. So he observed that there was a periodic or reoccurrence of elements with similar properties. So Mendeleev also arranged these elements in a increasing order of their atomic masses. And the elements which are getting similar properties, he kept one down to another in one column. Okay, in that way he arranged all the elements into a table that we call periodic table, because when the elements are written in the increasing order of their atomic masses, properties are being repeated from one element to other elements. Those elements which are having the similarity in the properties arranged into a one column, that is called periodic table. So he classified the elements on one law, that is stated as he stated that the law as properties of the elements are periodic functions of their atomic masses. So this is called Mendeleev's periodic law. It means that when elements are written in the increasing order of their atomic masses, properties of elements are being repeated between them, or some elements are getting the repetition in the properties. Based upon this law, he arranged that periodic table. Okay. Not only that success in giving periodic table, there are some more successful points in this Mendeleev's classification. Let us see here those. See, this is a Mendeleev's periodic table. Around 63 elements were known. He could able to classify all the elements into this periodic table. He could able to fit almost all the elements into this table. In that way, he succeeded. Okay, this is these vertical columns are called as groups. So suppose if you say this is one group, and these horizontal rows are called as periods. These horizontal rows are called periods. This is called group. This is called period. These elements kept in one column are considered to be having similar properties. Okay, this is periodic table given by Mendeleev. One of the most successful aspects of this Mendeleev's periodic table was that he was able to predict the unknown elements more or less accurately. Yes, not only arranging all the available elements into one table, he could predict some elements which they didn't come to know yet. The elements which are to be found still. For those elements also, he predicted certain properties, and he left some places in his periodic table. As he later to him, as he predicted, scientists they have discovered those elements, and they observed these properties are similar to the properties explained by Mendeleev. not only predicting the elements, he named those unknown elements also. In that way also he succeeded. For example, he left a place in his periodic table down to boron. He left a box there. He left a column. He left a place in that. As he left, scientists later they have discovered an element and which is exactly fitting into that place. And he named that element as Eka boron, means having similar properties as boron. As he expected, they found that element as as scandium, and it is having similar properties with that of boron. Not only that, some more elements like that. For example, he left a place down to aluminium, and he called that element which is to be found as Aka aluminium. Later on, they discovered that element and named that as gallium. Similarly, Eka silicon, which was discovered later and named as germanium. Okay, in this way, by predicting the unknown elements, he succeeded. One more important point in that is Mendeleev's predictive Mendeleev's periodic table simplified the study of elements because he classified all elements into different groups. Now, if we know the properties of one element in a group, we can apply the same properties for the remaining elements also in that group. In that way, it is made easy. It became useful in studying and remembering the properties of a large number of elements in simple way. Okay, they are the successful points in the Mendeleev's periodic table. Despite its success, there were still a few shortfalls in the Mendeleev's periodic table. Even though, as we told, it was the most successful than the remaining all. It was the first periodic table given. Even though he could be able to arrange all the available elements into one table, even though there are some limitations or shortfalls. Let us see those. The main one is, firstly, he failed to place the hydrogen correctly on his periodic table because hydrogen shows or it exhibits properties similar to that of alkyl metals as well as those of halogens. Alkyl metals means elements present in the first column like lithium, potassium, rubidium, cesium, francium. So hydrogen is also exhibiting certain properties which are similar to that of these elements or alkali metals. So he expected one place in the hydrogen in this column, and the same hydrogen exhibiting certain properties similar to that of halogens, means the seventh column elements. They are fluorine, chlorine, bromine, iodine, acetylene. So he expected one place in this column also. So in this way, he confused to give the exact position for hydrogen in his table. He proposed two positions. One more drawback in this is the discovery of isotopes. Isotopes of elements were providing to be a problem. So after the discovery of isotopes, he could not able to place them in his periodic table. For example, if you see carbon, carbon has three isotopes: carbon 12, carbon 13, carbon 14. But he could give only one place for carbon in this periodic table. He could not provide three places because these three are having different mass numbers. As they are having different masses, three places should be provided because this periodic table is based upon the masses, isn't it? So they should be given three places, but Mendeleev could give only one place. In that way, the placement of isotopes was in confusion. He could not provide places for the isotopes in his table. That is one major drawback. Okay, next. Instead of the above limitations, even though these are the limitations in the Mendeleev's periodic table, Mendeleev's periodic table was the best classification of elements and proved a milestone in the field of chemistry. Yes, even though it is failed, it led a correct way for the classification of elements in the modern way. So based upon this classification only, based upon the way or path laid by this classification only, modern periodic table was designed later. Okay, so even though it is failed or having some drawbacks, it is also one of the important classifications. Okay, thank you for watching our video. Please subscribe our YouTube channel AIMS Today and for latest updates and recorded videos.